Hello everyone, we are from Group 10 Section 3 of the subject Soil Mechanics and Foundation. Before we start, I would like to introduce our group members. Firstly, I am Joshua Lampun and I Jacob. And then we have Kah Won, Velerine Shan, Sarinata Saimun, and Ahmad Imaduddin Firdaus bin Abdul Karim. For our project, we are going to propose a ground improvement method for a land preparation located in Kendal, Indonesia. Ground improvement is required to increase the bearing capacity and shear strength of the soil, thus minimizing slip failure of the soil. Let us begin.
For the project background, it is stated that the owner planned to build factory, office and warehouse which is located in Kendal, Indonesia. The soil data of the area shows that soft clay is found to more than 20 meters, which is considered as not suitable for the construction works. Problem statement. The owner planned to build factory, office and warehouse at kawasan industri Kendal in Semarang, Central Java, Indonesia. Land preparation is estimated to be finished between 6 to 12 months before continue to upper structure work. However, soil data indicates that soft soil extends for more than 20 meters. It is not suitable for piling, as piling requires contact with gravel soil. It may take some time to determine the soil depth. As a result, another ground improvement method that is more appropriate for this project is used to improve the soil's strength reinforcement. To have a positive impact on all issues of stability, research and strong evidence or analysis must be included in this project as a reference. This is due to the fact that every cause and effect must be understood prior to beginning the construction project. Additionally, various cases must be examined in order to construct over deep soft soil deposits. The most appropriate solution for this project will be chosen from the cases.
For the soil replacement, we use soil import, where soil import is a ground improvement method which was a very old and simple method that can improve the bearing capacity of a soil. In this method, the poor soil, soft clay in this case, is simply removed and replaced by some more competent materials such as sand, gravel or crushed stone. In the construction site, the 6 meter of the soft clay from the surface is removed and then replaced by completely decomposed granite soil, CDG, before the installation of stone column. According to Gaffer Manar Basioni Hasham 2015, the replacement of soil with CDG soil can reduce the consolidation, settlement and increase the bearing capacity of the soil. After the soft clay is removed and replaced with CDG, the soil is continued to be compact with roller compactor. The purpose of soil compaction is to densify the soil and reduce the voids in the CDG. As the voids in the soil decreases, the settlement of soil after the structure constructed above the soil also decreases. The decrease in settlement of soil after the structure is constructed is important because settlement of soil can bring to permanent failure of the structure.
Like most ground improvement techniques, stone columns are used to reduce settlement and increase load-bearing capacity. They also accelerate soil consolidation as a result of the drainage capacity of the granular material within the columns, which act as a pore of water pressure evacuation points. Stone columns are effective in improving slope stability and preventing liquefaction by increasing shear strength within the soil. These vertical inclusions can be made of stone or sand and are installed in a grid pattern into the soft soils beneath the structure. But for our project, the aggregate will be replaced with used concrete cube ties that have the same compressive strength with the stone aggregate. after we do some analysis on the bearing capacity of the stone column before and after improvement, we found out that the stone column will increase 15% ground improvement when compared to the existing soil. Stone column is suitable for the improvement of soft soil or loose soil as they create vertical inclusions with high stiffness, shear strength and draining characteristic. The stone column will result in an increased bearing capacity and a reduction of the total and differential settlements.
After the installation of stone column, we continue with the installation of a post-tension rough foundation. A post-tension rough foundation can be said is a concrete slab that has stranded steel cables that are added for reinforcement and tightened after the concrete is hardened. The reason that we choose post-tension rough foundation is because of 5 reasons. The first one is because it is economical. Rough foundation is more economical than deep foundation because rough foundation only requires to carry out small open excavation of soil below the ground surface, whereas deep foundation requires special equipment to install. Then, less steel is required in post-tension rough foundation compared to normal rough foundation, and it also reduces the cost of the project. The second reason we choose post-tension rough foundation is post-tension rough foundation can reduce cracking. Post-tension is a method where the cable tendons adds the compressive forces in the concrete that help to overcome the internal tensile force from shrinkage. Next, less steel and concrete required for post-tension foundation comparing to normal rough foundation. And then, post-tension rough foundation is also simple to install. It's easier for workers to pour the concrete because the space and arrangement of the tendon cables. And lastly, it's easier to inspect and repair for post-tension rough foundation.
In conclusion, stone column is one of the effective methods in ground improvement. The use of rough foundation and import soil also increase the bearing capacity of the soil. Plus, safety measures should be also considered during the construction works. For example, soil import should be done before the installation of stone column to prevent the soil to settle or failure when the machine enters the site. That is all from our group. Thank you.